So we are going to solve a differential equation using the exact method. Now the exact method has two formulas that we need. And these are partial differential operators. Notice because our functions are mixed in with two variables, x and y. So the first step is we need to identify what our m and n are. So let's rewrite this equation as tan y minus 2 dx plus x secant square y. What's going on here? Plus 1 over y dy is equal to 0. So looking up, if the partial derivative of f with respect to x is m, then the partial derivative of f with respect to y is n. So this must mean that this is m and this is n. So now let's use equation the formula number 1. The partial derivative of the partial derivative of m with respect to y must be equal to the partial derivative of n with respect to x. So doing that, we have partial derivative tan y minus 2 is equal to the partial derivative of x of n, which is x secant squared y plus 1 over y. So the derivative of tan y is secant square y. 2 is a constant, so that's just 0. And then the partial derivative of x is 1, and secant square y is considered a constant. If y is a constant, then 1 over y is a constant, and the derivative of that is 0. So this is an exact equation, and we can now move on to the second part of this formula. This says that, let me use a different color. The partial derivative of f is equal to m. So let's write that down. The partial derivative with respect to x of f is equal to m. So let's plug in what m is. The partial derivative of f with respect to x is equal to tan y minus 2. And if we integrate both sides with respect to x, we will obtain the f function, and that will be equal to x tan y. Remember, tan y and 2 are a constant, so we just tack on that x minus 2x, and we're going to add a function as the constant because we're taking partial derivatives. If we took the derivative of a function with respect to x, there must be some gy function that we considered a constant and it got removed. We want to find that function. Now that function could be a constant, but we don't know. But to be on the safe side, we're going to keep it as a g of x function. so that when we take the partial derivative with respect to y, we don't lose that g of y. So let's look at what we have here. So we started off with the partial derivative of f with respect to x is equal to m, and we found what f is, but we don't know what g of y is. We don't know what that function of y that we lost when we took the partial derivative. So to find that, we could take the partial derivative of f with respect to y and set that equal to our n. So let's do that. The partial derivative of f with respect to y is equal to, so the partial derivative of y, x is considered a constant. This is secant squared y. X is a constant, so this is 0. And we have a derivative of the g of y function. Now if we look up what is the partial derivative of f with respect to y, well, that's n. And we have n is right here. So now we're going to set the partial derivative of f with respect to y is x secant squared y plus 1 over y is equal to x secant squared y plus g prime of y. This will cancel. Expect a lot of things to cancel as you're doing these. So we find that g prime of y is equal to 1 over y. Now if we integrate both sides with respect to y, we will obtain, remember what our goal here is to find the f function. The f function, we need to figure out what the g of y function is. So we're going to integrate. So now we find out that the g of y function is equal to 1 over y is just ln y. And now we can plug in this formula, this function right here. So f, and this is a function of x and y, is equal to x tan y minus 2x plus our ln y, and that is our solution to the exact differential equation that we were originally trying to solve. Now if we have that initial value, we'll find out what f of x of y is. Because up here, f of x of y is equal to 0. Because the 0 is right here. So let's find out what f of x is actually equal to. So we have the point 0, 1. So f of 0, 1 is equal to 0 tan 1 minus 2, 0 plus ln of 1. And f of 0, 1 is equal to 0 minus 0 plus 0. So f of 0, 1 is equal to 0. Therefore, x tan y minus 2x plus ln y is equal to 0. Well, there you have it. The solution to the exact differential equation is this.